Very good morning to all of you. Today I want to start experiment number 5. Title of experiment is Determination of Acidity of the given sample. The course outcome of this experiment and this subject is 4 course outcomes. So first course outcome is acquire ability to conduct experiments and estimate the concentration of different parameters. Second course outcome is compare the result with standards and discussed based on the purpose of analysis. Third course outcome is determine type of treatment, degree of treatment for water and wastewater. Fourth outcome is identify the parameter to be analyzed for the student project work in environmental stream. So these are the course outcome is decided. The subject of title is Environmental Engineering Laboratory. Subject code is 18CVL67. This comes in 6th semester of civil engineering department. Let us see, these are the apparatus are used in the environmental engineering laboratory for different types of experiments are required to conduct. So these apparatus are you should be used. Okay, all these apparatus I have already explained in experiment 1. So why I have given these first slides in all the experiments means all of you remember these apparatus. Okay, so then you conduct required experiments according to procedures. So theory about the acidity of the waters. Acidity of the water is its capacity. Acidity of the water is its capacity to neutralize a strong base to a fixed pH. It is caused by the presence of strong mineral acids, weak acids, and hydrolyzing salts of strong acids. However, in natural unpolluted fresh waters, the acidity is mostly due to the presence of free carbon dioxides in the form of carbonic acids. So this is the background about acidity of the waters. What is the principles of this experiment? Acidity can be determined by titrating the sample with a strong base such as sodium hydroxide using phenolphthalein as indicator. If the sample has strong mineral acids and their salts, it is treated first to pH 3.7 using methyl orange as an indicator. This is called methyl orange acidity. If the sample is treated directly to pH 8.3 using phenolphthalein, the resultant value is totally acidity. The titration method is suitable mainly for the samples which are colorless. The titration method is suitable mainly for the samples which are colorless. The original color of the sample may interfere with the indicator colors. Let us see which are the apparatus are required to conduct these experiments. Burettes are required, pipettes are required, conical flasks are required, volumetric flasks are required, beakers are required, spoons are required, glass rods are required, weighing balance is required, dropper are required, etc. So these are the apparatus are required to execute this experiment. Then which are the reagents are required? So this is the most important part of this experiment. First you prepare the reagents as per the experiments title. So first reagent is required. How to prepare? That is standard sodium hydroxides of 0.05 normality. Standard sodium hydroxide of 0.05 normality is required. So then how to prepare these reagents? Let us see. Dissolve 2 gram sodium hydroxide in 50 ml distilled water. Dissolve 2 gram sodium hydroxide in 50 ml distilled water. This 50 ml is made up to 1 liters of double distilled water. Now this becomes standard sodium hydroxides of 0.05 normality. Then second reagent is sodium thiosulfate is required, that is 0.1 normality. Third reagent is required methyl orange indicator. Fourth reagents are required phenolphthalein indicators. And next is carbon dioxide free distilled water. So these are the reagents are required to conduct this experiment for the given samples. Procedures. So you follow the procedures, then we are getting the required title of experiments results. First step, take 100 ml of given sample, that is tap water, in a conical flask. And second step, add a drop of sodium thiosulfate solution to remove the residual chlorine if present. This step is to be applied for sample other than seawater in surface water. Add 2 to 3 drops of methyl orange indicator. If the solution turns yellow, the methyl orange acidity is absent. After addition or after adding of methyl orange indicator, if it turns yellow, the methyl orange acidity is present. If it turns pink after addition of methyl orange indicator, if it turns pink, titrate against 0.05 normality sodium hydroxide with burette. At the end point, color changes from pink to yellow. You do the titration up to color changes pink to yellow. Next, now note down the volume of sodium hydroxide added. Let it be V1 in mLs. Note down the readings in burette in mLs. Next, now add a few drops of phenolphthalein indicator to the same samples. Now add a few drops of the phenolphthalein indicator to the same sample and titrate further with sodium hydroxide until the color turn pink. Okay. Note down the total volume of sodium hydroxide added. Let it be volume V2 in mLs. Okay. Note down the total volume of sodium hydroxide added. Let it be V2 mLs. Results. The total acidity of the given sample of water is, we are getting in milligram per liters. Now see observations and tabular columns. Okay. So let us see how to write the observations. So in observations, first in burette 0.02 normality sodium hydroxide solution is there, and in conical flask 100 ml of sample plus 2 to 3 drops of methyl orange indicator plus 2 to 3 drops of phenolphthalein indicator is the indicator used. Methyl orange solution and phenolphthalein solutions are used. These are the indicators. Next, endpoints, that is colorless to permanent pink. Endpoint is colorless to permanent pink. This is the observations. And tabulations, how to enter the reading in tabular column. So this is the tabular column. Serial sample details, description of sample, volume of sample taken in ml, phenolphthalein indicators, that is burette reading in mLs, IBR, next FPR, that is initial burette reading, final burette reading, then the difference. And next this column is mean burette readings, that is MBR in ml. So here you do the 3 trials, okay, 3 trials, and you take the sample is tap waters. Each tap water is 100 ml, and similarly you take synthetic water of 3 trials and do the titrations. So then you do the mean value, that is MBR. So then do the calculations. Okay, this is the calculations. Acidity in milligram per liter is given by the formula MBR into 1000 divided by ml of sample taken. This is step 1 acidity formula. Next, for sample 1, that is tap water, acidity in milligram per liter equal to MBR into 1000 divided by ml of sample taken. We are getting in milligram per liters. For sample 2, that is synthetic water, acidity in milligram per liter equal to MBR into 1000 divided by ml of sample taken. We are getting in milligram per liter reading. So this is the sample of calculation. So like you complete the calculations with all the 3 readings with each samples. So then rate the comments based on the results. I have shown here sample of comments. As the acidity of tap water is dash milligram per liter, which is within the permissible limit of 50 milligram per liters, you assume as a 40 milligram per liter or less than 50 milligram per liter. As per IS 10500, therefore tap water is allowed for the use. And as the acidity of synthetic water is this much milligram per liter, it is not allowed for the uses. So this is the comment based on the results. References. So these are the references or reference. 3 references are reference. Okay. Thank you one and all. Next experiment I will be continue in next class.